Hello, Mario. In this video, I'm going to take a look at perimeters, circumferences, and how they all relate to the circle. So let's get on with it. First of all, perhaps need to get a bit of a handle on the circle and what the various parts and things of it mean and are. So first word up is this word perimeter. Perimeter. It's the distance around the outside of a shape, any shape, not particularly a circle, but the perimeter. For example, people might talk about the perimeter fence, or in military terms, protecting your perimeter, which means the area or the line outside of the area that you're occupying. So now let's have a look at circumference. You can see it's got circumference, circum in it, which indicates that it's possibly about the circle. The circumference is the distance around the outside of a circle and only a circle, nothing else. So you could call it, or also known as, the perimeter of the circle. Could be called the circumference. The diameter of a circle is the distance across a circle, but it must go through the center. So it's always the longest line that you can draw across a circle, and it goes through the center of the circle, which is quite important point in a circle. So we usually use C, a capital C, for circumference, and a little d for diameter. Now there's also the radius, which is the distance from the center of the circle to the outside, and that's the distance between the 2 points of our compass when we're drawing a circle. That's the distance between the point and the pencil if you're using that sort of compass. And it's probably, you can see from there that the radius is equal to half the diameter, or the diameter equals 2 times the radius, but more on that later. Now, pi. Pi is a very important number in mathematics, and it has been known for quite some time, since earliest times. In actual fact, it is the ratio of the circumference of a circle to its diameter. So pi equals C, the length of the circumference, or the distance, always usually measured for us in meters, divided by or over the diameter, or again a distance measured in meters. Now pi equals 3.14159265359, and it keeps on going and going to infinity. There is always another number for approximating what pi is. We can't write it down as a specific number. It is what we call irrational, and it cannot be expressed as one integer over another as a fraction. Some people are able to memorize pi to 1000 plus decimal places, and there are various competitions and things for this. There's competitions to actually calculate pi to hundreds of thousands of decimal places, and these are pure mathematical activities that mathematicians sort of enjoy doing. But for our purposes, probably using pi on our calculators to maybe 5 to 10 decimal places is more than amply sufficient for what we want to do. Now the one thing about pi is that it is this ratio of the circumference to the diameter. It's the same for all circles, no matter how big or how small. So if you take any circle whatsoever, if you take the earth itself and measure the circumference, the distance around the outside of the circle, and then measure the diameter very, very accurately and divide the circumference by the diameter, you will get pi. 3.14159265359 blah 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 through to infinity.
Pi is the circumference of a circle divided by its diameter. In this example, we will let the diameter of this circle be equal to 1. Then, if we measure the circle along the graph, we will receive pi. This concept has been known for thousands of years.
Now, it also pays to remember that the diameter of a circle equals 2 times the radius. D for diameter, little d usually, equals 2r, where r is the radius, 2 times r. Now, we can write these sort of ratios down, and typically they are written down in this little triangle thing here, which helps us work out all of the other little formulas to use. So if we put c on top, pi underneath there just on the left hand side, and d in the right hand side, remembering that d equals 2r, so we could use d or 2r. Now if we want to find the circumference of the circle, what we do is we put our finger over c in our little diagram here. Put our finger over c, and there you have it. There's the formula for the circumference. C equals pi d, or c equals pi times 2r, or 2 pi r if you rearrange the multiplication together, because you can do that with multiplication. You can rearrange them. 3 times 4 is the same as 4 times 3. 2 times 3 times 4 is the same as 3 times 2 times 4. So you can rearrange your multiplication ones. That's fine. It's called, got a name for that law. Now if we wanted to find out what d is, put your finger on d, and you can see from our little triangle c divided by pi. If you wanted to find out what r is, that's just slightly trickier, because you've got 2r there. Put your finger on 2r, and it's c divided by pi, but that would give us 2r, so you must divide by 2, and you get c divided by 2 pi. So using the little triangle thing there, you can work out all your formula if you want to, and there's other ones where this little triangle thing works. So if you want to find out what pi is, put your finger over pi, and it's equal to c over d, or c over 2r. Now we're armed with all this information. What we need to do now is let's crack on and do a couple of examples here. So, first example. Calculate the circumference of a circle with a diameter of 6 centimeters. Okay, so first thing to do, and what I've done here in the magenta or purple, is to indicate if you were in a test situation or an exam, where you would get your marks. So first thing if I would do is draw a diagram. So there's my circle, showing my diameter going through the center, and it's 6 centimeters, my diameter. Next thing, I've got my little triangle thing up there, put my finger on C, and I've got pi, C equals pi times D. So state the formula that you're using. Alright, now let's fill in some values. C equals pi times 6 centimeters. Now, don't write pi out as a number. Generally, we'll do that on your calculator. Okay, because it's more accurate on your calculator, remembering that it goes for infinity. So the more decimal points you have, the better. So let's multiply that out and round it. So we get equals 18.85 centimeters. Don't forget your units. Okay, and 2 decimal places show what you're rounding it to, so how accurate it is. So there you go. Now, when you're doing these as exercises, and you might be doing 4 or 5 or one's the same, you should always follow the rules, because we're practicing for an exam or a test or something. So we should practice as we mean to go on. There's no point just writing down the answer. Each time, follow through the same steps. Draw the diagram, state the formula, Fill in the values. Multiply it out. Show your units. Show your rounding. Practice as you mean to go on. Practice as you mean to do in the real thing. Just like you do with sport, like rugby or things like that. You don't take shortcuts and just go at practice and just put the ball down under the goalpost and say, well, that's how you score a try. You've got to go through all the processes to get there. Alright, let's have a look at another one, slightly different. Calculate the circumference of a circle with a diameter of 5.04 meters. Alright, let's draw a diagram. As there, put in the 5.04, that's the diameter. State the formula, C equals pi d. Fill in the values, equals pi times 5.04 meters. Okay, multiply it out, 1.6 to 2 decimal places. Generally, if the information that you're given at the start is to 2 decimal places, you should show your answer to 2 decimal places, just as a general rule. Here's another one. Calculate the circumference of a circle with a radius of 6 meters. Draw the diagram. Note that it's the radius this time, not the diameter. So, get the correct formula. C equals 2 pi r. Fill in the values. C equals 2 times pi times 6 meters. Include the units in your calculations. That way you can keep account of them. Calculate that out. 37.70 meters to 2 decimal places. All done. Now for a word problem, but different, you've got to identify the problem, break it down to the earlier one that you did, to the one you did earlier. A circular traffic island has a diameter of 25 meters. How far is it around the island? Okay, draw the diagram. Put in the diameter. C equals pi d equals pi times 25 meters. Okay, multiply it out. 78.54 meters. And in this particular case here, I've forgotten to put in what I've rounded it to, so I'm just going to do that now. Hopefully, if I can just get my pen to work. Okay, I can see now why I've done that, and I'll just put in here brackets like so, and 2dp. So in a test or an exam, I could possibly maybe lose half a mark or something like that for not showing the rounding and what have you. Now finally, let's just go a little bit further with this, and we're going to have a look at situations now where we perhaps don't want to find out the total circumference around a circle, but it's part of it. So let's have a look at a circle. And first of all, we all know that there's 360 degrees in a circle. So if we start from a point in a circle and go full way around, that measures 360 degrees. So that's a full circle. So we all know on our skateboards and motorbikes and cars that we can do a 360. And that's when we start and finish looking in the same direction. We could do a 180. And that's where we start looking in one direction and we do our 180 and we're looking in exactly the opposite direction. 180 degrees, half a circle, sometimes called a semicircle. And so it comes on to the 90 degrees, which of course is a quarter of a circle. Now 180 degrees, half a circle, 180 over 360 equals a half. If we divide top and bottom by 180, which we can reduce it down to a half. 90 degrees is a quarter of a circle. It's also 90 degrees is a right angle, a quarter circle. Now, any fraction of a circle, if we know what it is in degrees, we can put it over 360 to work out what fraction of a circle it is. Like 120 degrees is a third, and so on and so on. So let's have a look at an example. Calculate the perimeter of this shape. Note we've said the shape, so there's a bit of a circular part to the shape, but there's also the straight bit across the bottom of the shape, 18 meters. So the arc perimeter which is the perimeter of the arc there, is 180 over 360. That's how many, half a circle, times pi times d. So I might just put in there, just for the sake of clarity, so that we can show where the 180 is, and we'll put that in there in magenta if we can. Here we go. Yeah, so we'll just try and put that in there like that, coming up. Oops. So we just got to get it started, and then try to put it in there like that. Well, that's not going too well, but yeah, here we go. So we just put that in there like that, round through there like that. Okay, and that's just remember that that's 180 degrees. That's a 180 degrees. Okay, it's a semicircle. Okay, so there we go. A half times pi times 18 meters, which equals 28.2743. Now that's just for the arc bit. So the shape perimeter is the arc bit, the 28.2743. I've kept 4 decimal places, plus the 18 meters across the bottom. And that should give us 46.27 meters, 2 decimal places. And for the trickier word problem, an engineer designing a car park needs to know the length of curb from A to B. So this might be a bit of curb and channel, so he needs to know how long that's going to be. And shown there that it's got an angle at the centre of the 2 radiuses there of 75 degrees. So the arc A to B equals 75 degrees over 360. That'll give us the fraction of the total circle times 2 pi r. 2 pi r is give us the circumference of a circle that was 16 meters in radius. Note that it's radius, so that's 75 over 360 times 2 times pi times 16. We put that in our calculator, multiply it out, we get 20.94 meters. Okay, to 2 decimal places. So there you are. There's a little bit of information about finding the perimeter of circles and parts of circles and arcs of circles in various different situations. I hope it's helpful for you going forward with your understanding of mathematics, circles, perimeters and circumferences.